All right, welcome. In this video, we're going to start in on our investigation of trigonometry, which is going to be a really big component of AP Precalculus. And today in this video, what I'm going to be doing is kind of just confirming some stuff that you hopefully already knew from geometry class, and then adding in a little bit of vocabulary. So to start, we're going to talk about sine and cosine and tangent, something hopefully you've heard about before. So we've got this right triangle. And that's always going to kind of be where we start with this stuff, with the trigonometries, with a right triangle. And so I need to kind of label the sides in the same way you may have in a geometry class. Okay, so first thing that might not be familiar is this letter over here down in the bottom left of the triangle. So that's a theta right there. And so that's going to be a variable that we're going to use in this class to indicate the measure of an angle. Okay, so this angle, it could be a little bit wider, and that would be a different value of theta. Okay, so and then we're not going to really talk too much about like the actual measure of these things in this video. That's something we're going to address kind of in the next one. For now, we're really just thinking about these ratios of sine, cosine, and tangent. Okay, but because it's a right triangle, the side across from the right angle, that's going to be the hypotenuse, the longest side. Okay? Then there's going to be two legs, and the two legs are the sides of the triangle that meet at a right angle. And so there's the one that's kind of across the triangle from theta, and we're going to call that the opposite leg. And then there's the one that's kind of nearby to theta, kind of closer. We're going to call that one the adjacent leg. Okay? And you remember the acronym from geometry class, right? It's SOHCAHTOA. And so I'm just going to kind of copy that in. And what that means is that sine is equal to opposite over hypotenuse, and cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. That's what that acronym stands for. And the idea is that somehow for a fixed angle, the ratio of, say for sine, the ratio of the opposite leg to the hypotenuse is going to be fixed. And let me show you what I mean by that. All right, so suppose I've got this triangle here. And it's got side lengths of 6 and 8 and 10, and it does form a right triangle. You can check it with the Pythagorean theorem, or you remember, 3, 4, 5. But what we can do is, what if we just, we were talking about this angle theta right here. I'll probably put that in there. What if we cut this triangle in half, but kind of left the theta angle sitting where it was? And I suppose that means, that depends on what you mean by cut it in half, but what I meant was like, okay, what if I just kind of like left theta the same and just only went to 4 instead of to 8? Just say that's what we're doing. Okay, well then if that's 4, kind of the nature of similar triangles, that's going to be 3 and that's going to be 5. And okay, yeah, that's another similar or a familiar Pythagorean triple. But if we think about sine of theta, on the black triangle it's 6 over 10. That's 0.6. But on the blue triangle it's 3 over 5, which is still 0.6. And so what we're saying is, like it doesn't really matter what the size of the triangle is. For that given theta, the sine is going to be 3 over 5 or 6 over 10. And then if we had just a little bit more information about like maybe one of the side lengths, then we could figure out the rest of the stuff on the triangle. All right, so let's, jump in and do a quick example. So for the triangle below, find sine theta, cosine theta, and tangent theta. So the first thing we need to do is we're going to need to find this missing side length. And now maybe you just, like, dude, you just showed me, but I think most of y'all are probably recognizing that B is going to need to equal 4. But I need to remind you that something that they just assume you come into AP Pre-Cal knowing is the Pythagorean theorem. So for a right triangle, the one leg squared plus the other leg squared, that's going to equal the hypotenuse squared. Okay? A squared plus B squared equals C squared. You've known that for a while. So we'd say, all right, 9 plus B squared equals 25. That means B squared is going to equal 16. And for now, we're going to assume the sides of these triangles is going to be positive, so that would give me B equals 4. Okay. Right, so I think since we're still getting started, it might be good for me to just like kind of label my sides. So I know that vertical leg is 4 and the horizontal leg is 3 and the hypotenuse is 5. So I'm going to start with that. Hypotenuse is 5. And then they gave us this leg of 3, which was near theta, so I'm going to say that's the adjacent side, the adjacent leg. And then 4, that would be the opposite leg. So, if we're starting off trying to find sine, cosine, and tangent of theta, okay, remember, SOHCAHTOA, sine is opposite over hypotenuse. So sine of theta is going to equal 4, the opposite, divided by 5, the hypotenuse. Cosine is adjacent over hypotenuse, so 3 divided by 5. And tangent is opposite over adjacent, that's going to be 4 over 3. Okay, so we found sine and cosine and tangent of theta, and that's all they asked, so that'll be all for us, and we'll just move on. All right, now let me tell you about a trig identity. Okay, and this might be where we start to diverge from what you did in geometry. A trigonometric identity is going to be a formula that's true regardless of the angle that we're plugging in. Okay, and so the first one I'm going to tell you about is tangent of theta is sine theta over cosine theta. And actually, I do believe that by the end of this video, I will have told you all 4 of the identities that are like essential for AP Calculus. And somehow all the rest of the ones that we're going to learn, while still important, are not going to be ones that are might be labeled essential for AP Calculus. Okay, so proof of this. Before I get in, I'm going to tell you there's going to be more proofs this semester. You know, when we get into doing the geometry and the trigonometry and stuff. But still, all of the proofs that I'm going to do in the videos, like that aren't just like completely separate, I'm doing them because I think there's like some value added to them and can kind of understand why these things work the way they do. So tangent of theta is sine of theta over cosine of theta. Okay, I'm going to work on the sine over cosine and just kind of like work it around until I can show you that that's equal to tangent. Okay, so sine over cosine. Now, if we think about this in terms of like opposite, adjacent, and hypotenuse, sine theta, that's SOHCAHTOA opposite over hypotenuse, and cosine is adjacent over hypotenuse. So I'm just going to like kind of write it out like that. And then I've got 2 fractions divided by each other. And that's one thing that, you know, learning about trigonometry is going to be really good for, is like kind of like restoring those fraction arithmetic skills. And so we need to divide fraction by fraction. I think at least, you know, if you went to middle school in the district I work in, you probably called that keep, change, flip, right? So we kept the numerator the same, we changed the division to multiplication, and we flipped the denominator. Okay, then I'm going to notice, oh, hey, I can cancel off the hypotenuses, right? And so I'm going to do that. And then what I'll be left with is opposite over adjacent. Now, the thing about opposite over adjacent is we already know that that's equal to tangent theta. So I'm going to go in here and I'm going to say, all right, that's equal to tangent theta. Okay, and so that's why sine theta over cosine theta equals tangent theta, and we'll see that that'll actually probably be pretty useful for us in this class and also in the next class. Okay, now for something new. Let's talk about secant, cosecant, and cotangent. Okay, these are, at least based on, you know, surveying the students in my class, terms that you might not already be familiar with, especially in terms of like trigonometry. Okay, so I think what I'm going to tell you is that they're very related to sine and cosine and tangent. Okay, and also I've relabeled this standard diagram with X and Y and R. So we're just going to use some letters. This is going to be too much to keep writing hypotenuse and adjacent, right? It's not going to be a good way to remember stuff besides SOHCAHTOA. And also, you know, where we're headed, I'll actually show you. We're going to kind of suppose this triangle is somehow oriented at the origin. And we're going to put like an XY axis there. And so that's the, you know, this diagram here makes it a little bit more clear why we might be interested in calling that horizontal leg X and that vertical leg Y. Okay, but more on that, you know, in the lessons to come. Let's get rid of that. Okay, so I'm just going to tell you that secant of theta, that's the one, it's related to cosine. It's a friend of cosine. But, you know, whereas cosine of theta would be adjacent over hypotenuse, x over r, secant of theta is r divided by x. Okay, cosecant, that's the one that's friends with sine. And it works the opposite of the way you expect. You would expect cosine would be friends with cosecant, but they're not. Okay, cosecant is the one that's friends with sine, and so if sine of theta is y over r, then cosecant of theta is going to be r divided by y. Okay, and then cotangent of theta, okay, that one is friends with tangent, like you would expect. But what's going to happen here is, let's see how you can see that. Okay, tangent is opposite over adjacent, y over x, so cotangent is x over y. Okay, and these, they're not the most important formulas in the world, right? Secant, cosecant, cotangent, we will work with them a little bit in this class. You know, we'll need to know a couple facts about them in calculus, but they're not the most important. I don't want you to get the wrong impression and think that these are more important than sine, cosine, and tangent, because they're not. Okay, what I was also going to say about this, I think the identities are down below. Let me think. Can't think what it would be. So let's just go on and, yeah, let's actually compute some secant, cosecant, and cotangent values. Okay, yeah. But first, I'm actually going to switch the order here. I'm going to go down and talk about the identity first. All right, so these reciprocal identities, we will be, you know, kind of needing to know these. These are the other 3 that we need to know for AP Calculus. Okay, like I said, secant is friends with cosine. And specifically, you might have seen it, is like kind of the opposite, like the top and bottom switched. And I do probably need to remind you, it might have been a while, especially if you're just coming off a long break, that 1 over A divided by B, that's the same thing as B divided by A. Okay, that does work. It does work like that. So if secant looks like, cosine but flipped, we are going to be able to say that secant theta is 1 over cosine theta, and that cosecant of theta is 1 over sine theta, and cotangent of theta is 1 over tangent theta. And these are going to be, important identities for us to know. Okay, and also, this is how I would recommend computing values of secant and cosecant and cotangent personally. That's what as you'll see up above on this example, I'm just going to find sine, cosine, and tangent and flip. Okay, yeah, so let's do it. So here we've got a triangle. It's got a hypotenuse 13, and one leg is 5. That does mean that the other side leg will be 12, because 5, 12, 13 is a Pythagorean triple. Okay, and it seems like, based on what I can see, it doesn't seem like Pythagorean triples are going to be like a huge deal in AP Pre-Cal. Nor are the triangles, but the triangles are the tool that we're going to use to unlock these trig problems for AP Pre-Cal. So we're gonna use a lot of triangles, but kind of as a tool, as our diagramming method. So I'm gonna go in, I'm gonna find sine, cosine, and tangent. All right, there they are. You already saw me do that once for a different triangle. I don't think we're going to need to go in and do SOHCAHTOA again. Okay, what we are interested in secant, cosecant, and cotangent. So what I'm going to do is kind of like on the same line. Okay, I know that secant is the reciprocal of cosine. So I'm going to put that right there. Secant of theta, if cosine of theta is 5 over 13, secant of theta will be 13 over 5. Sine is the one that's friends with cosecant, so cosecant theta is going to be 13 divided by 12. I'm just flipping, right? Okay, so, and then cotangent theta, that's going to be 5 divided by 12, and that's how we're going to find values of secant, cosecant, and cotangent given a triangle diagram. All right, now I want to talk to you about inverse trig. Now, we're not going to do a whole lot with it in this lesson, but we do need to know that it's out there, right? We just kind of came off of a unit of studying the nature of functions and occasionally their inverses, so this is going to fit with that. Okay, write an explicit formula for theta. We don't really have a way to, write a formula for the angle in terms of those two side lengths. What we do know is that 5 is the hypotenuse and 2 is the opposite leg from theta, which means, okay, opposite hypotenuse, we should be able to use like sine as a relationship. And so I'm going to write down what I know for a fact right now, which is that sine of theta equals 2 over 5. Now, like, kind of the way I pitched it in class today was like, okay, if you had e to the theta equals 2/5, what would you do to both sides? Everyone was like, oh, I hit it with natural log. Great, okay. And, what is natural log to e? And I got a little quiet. But it was like, okay, we're going to hit both sides of this equation with the inverse function. And so we need to hit it with the inverse function for sine. And I'm not telling you a whole lot about it, except for it's out there. And we're going to call it inverse sine. Okay, it's not a big deal. Okay, so what we're going to do is we're going to take inverse sine of both sides. And much like natural log and e to the thing, or square and square root, inverse sine and sine, they undo each other. So that means that I will have theta equals inverse sine of 2 over 5. And I am assuming that, maybe you did a little bit of this work in geometry and you ran that through a calculator and you got some number of degrees, but that's just not going to be the focus of this trig class. So we're just going to stop right there and say, all right, theta is the angle whose sine is 2 over 5. And that is an entirely, like, there's only one angle whose sine is 2 over 5, at least on a triangle that looks like this, for anybody that, like, knows where we're going with this stuff. What I said was not entirely true, but, for this triangle, if we're kind of fixed in there, there's only going to be one theta that works, only one acute theta that has sine equal to 2 over 5. All right, here's 2 more for you to try, and just warning you right now, as you can probably tell, these figures are not drawn to scale, but all the same, you can just believe them, and, write a formula for theta. We're going to do the same thing, and so I think I'd like for you to try this on your own. It's just like the difference between these two and the one right above it is that we're not going to use sine, right? It's going to be cosine and tangent. So try to, feel your way through this one and see if you can write a formula for theta in terms of, the 6 and the 5 and the 3 and the 6. All right, there you go. So on the one on the top of the screen, okay, started with what I know. I've got an adjacent and a hypotenuse, so I know cosine of theta is 5 over 6. Then I'm going to hit both sides of that equation with inverse cosine, and inverse cosine of cosine theta does just give me theta. And so theta will be the angle whose cosine is 5/6. Okay, that's what it means. And then we'll do the same thing for tangent. Tangent of theta equals 3 over 6, opposite over adjacent. But, this is still AP Pre-Cal, so we are still going to need to be simplifying our answers. And so we need to take that 3/6 down to a 1/2. Okay, then we're going to hit both sides with inverse tangent, and we'll say theta is inverse tangent of 1/2. Okay, now before I go any farther, I do need to tell you a little bit about notation. Now, as you may know, I have a whole lot more experience with AP Calculus than AP Pre-Cal. And I know for a fact that on every AP Calculus exam on the cover sheet, it's got two disclaimers. One's about the domain of a function, and the other one is about inverse trig. And so sometimes in some textbooks, in some situations, you might not see that inverse sine, inverse cosine, inverse tangent notation. You might see it called arc sine, arc cosine, arc tangent. And I'll be able to show you a little bit better, over the next few lessons or few weeks, or really, I guess, the rest of the course, why the arc terminology that fits here. Really, it's an arc whose sine is x, but we haven't really talked about circles at all. It's only triangles at this point. So I'm just gonna I want you to be aware that they mean the exact same thing. They're synonyms. So if you talk about inverse sine of x or arc sine of x, that's the exact same thing. I don't want anybody to just be confused on the nomenclature there. And I think that's going to be all for this video. I'm going to split out the special right triangle discussion into a separate video because this is really kind of the fundamentals of trigonometry: sine, cosine, tangent, secant, cosecant, so cotangent, and inverse trig. And so I'm just going to stop here for this one. But if you're in my class and you're needing to see the whole lesson, you're going to need to go on and watch the next video, but I'm sure at this point it's probably already up on screen ready for you to click on. And so that's going to be all for this video. Thanks for watching. Hope to see you in the next one.